who gets allocated the right water based on water usage, water quality. Needs may vary by season, and perhaps there's a way to do trade-offs. But then you start to look at things like conservation, habitat, fish and wildlife impacts, so that you can really manage this watershed as a whole, as opposed to, I'm Sonoma County, I'm the wine grower, I'm a utility plant, and I only care about the water that I'm using. And we found that this is actually a very replicable model, and it applies not just here in the U.S., but around the world. One project we're working with is on the Hudson River, similar in nature. We're working with the Beacon Institute, which is a group responsible for monitoring and kind of being the conscious of what's going on in the Hudson River. And the goal of the Beacon Institute is to put together a river and estuary observatory network. So basically a virtual version of the Hudson River. Through a combination of sensors and models and the appropriate technology to scheme those together, can you go online and look at any part of the Hudson and be able to tell what's going on from a chemical, biological, and physical parameter point of view. So that's the goal. We have sensors already deployed. We're nowhere near have the whole 300 miles of Hudson monitored yet, but that's, we're starting, and we've already got some data coming in, streaming in, and giving us insight, for example, into the salt wedge that comes up the Hudson, sometimes as far north as Poughkeepsie, which is like 50 miles north of New York City. So there's new insights being gathered, and what John Cronin, who leads the Beacon Institute and was formerly the riverkeeper for the Hudson, his message is that the changes in the Hudson occur, I should say 90% of the changes occur like 2% of the time. So how are you going to be able to really see what's going on if you don't monitor it all the time? And so that's really what's driving him to put together this kind of network. And we've seen interest in this from users in China, in Korea, and other parts of Europe. So we're also working in Ireland, a project called Smart Bay. This is work we're doing with the Marine Institute in Ireland. They are an institute on the west coast of Ireland, on this nice, pretty scenic part of Ireland called Galway Bay. It's a very multi-use piece of water there. There's tourism there. There's a lot of beaches. There's wave energy research. Obviously, there are some watersheds that flow into it. There's shipping lanes that go through there. So there's a lot of need to understand what's really going on in Galway Bay. Whether it's tidal flow, wave heights, temperature, plankton, because there's also an aquaculture industry that operates on this bay. And so the problem statement was, how do we get all of these different stakeholders to look at one set of data for Galway Bay and be able to collaborate and make better decisions for the bay as a whole. So we put together Smart Bay, which is really a shared information collaboration platform. That not just the sensor data, but a lot of other data comes in, whether it's historical data or SMS data from people on the ships or lifeguards on the beaches. All the data from various sources streaming into this set of databases and populates portals. Now the cool thing about it is the portals could be customized depending on if you're the Coast Guard or a fish industry guy or a water treatment plant. You may be interested in different parts of the bay and what different things are going on. But the goal then is to bring all together so it's in one place so you can manage it as a whole. And then you can start having alerts generated for weather threats or pollution alerts. And we're also bringing now, in the second phase of the Smart Bay, we're bringing in more analytics so to take all this data and be able to predict. So for example, if somebody's on a ship and they see some sort of debris or in the bay, they can text that in with the appropriate coordinates, and the models can start cranking away and see where that debris is going to flow into. So could it impact the beach? So, okay, we got to close the beach. Or could it impact the agriculture guy? So he needs to decide what to do. And here it kind of shows all the different stakeholders that are involved in this, from not just fisheries, the tourism, but also policy people looking at this, safety. The European Union has several water framework directives that kind of govern how water is supposed to be managed and monitored. And this is actually a very, it's being touted as a kind of a reference for what the framework directives can use to implement some of their goals. We've also taken this same tool and applied it to beach monitoring specifically. A project that's called Splash with the Ireland EPA. And this is a tool that allows all the beaches in Ireland to be monitored and displayed in real time in terms of what their water quality is, and whether they're open or closed, or whether any kind of coliforms or other contaminants that are impacting the beach. So it's a GIS map-based tool that allows you to zoom in and understand exactly what's going on. They call it bathing water, but it's really beaches. So it's uploaded directly from the local authorities to this site, and so then everywhere, everybody can go to this site over in Ireland. You can even go to the website and see what's going on in your favorite beach. We're also working with the Nature Conservancy. Nature Conservancy is an NGO very focused on protecting natural waters and habitats. The project we're working with is called Water for Tomorrow. It's the IBM contribution here is really a software modeling framework that allows you to, through a very map-based environment, predict land use scenarios through models and the appropriate remote sensing data. We're starting in the South America region in Brazil, Paraguay, and what you can do is you can look at land cover and say, well, what if I change this land cover to be this percentage, or what if I change this forest to be a farm, or to be even cleared for some sort of urban development? What's the impact of that going to be downstream on water quality? What's the impact going to be on fish and wildlife? And so this tool allows you to generate all those scenarios and then collaborate with other policy makers and planners so you can really understand what the best decision is for that region. They're starting in South America, but looking to deploy the same tool in China along the Yangtze, and then also in parts of Africa as well. The other area we're focused on is the whole wastewater side. Many of you probably know the issues in many cities in the U.S. as well as around the world. They have what's called combined sewers. When it rains, a lot of the rainwater goes into your sewer system. Now, your sewer system is typically only able to accommodate a certain capacity. And when it rains, you've got all this extra capacity water that something has to be done with it. That's why you see in some of the cities in the Midwest, they're digging big tunnels. Chicago was a big tunnel just to capture, stormwater. If you don't have the capacity to capture the stormwater, what you have to do is you have to dump untreated water into your closest body of water, like Michigan or your Ohio River or whatever. And so the EPA is really, finding obviously all the water authorities to do this. There are over 700 water utilities or cities, I should say, in the U.S. that have CSO violations. So a lot of focus on how to do things better, and the most obvious thing to do is, well, let's just build a big tunnel. We'll just capture that 100-year storm, all that water, and we'll be fine. What we'd like to say at IBM, along with some of our partners, is perhaps there's a smarter way to do it through the use of sensors and predictive tools. So if you have sensors distributed throughout your sewer system, you can tell perhaps